I'm founder of QC Data Analytics. Vishal, I'm waiting for the control here.
Yeah,
Thank
give
you.
me.
Thank you.
So
Great.
just a moment. Just a moment. So I'm muting myself, but if you have any questions, I encourage you to keep on putting as and when they come. But we will try to answer all of those questions towards the end of the webinar because we have lots to cover here. Right? Thank you. Go ahead.
Great. Yeah, thanks, Vishal, again. Great. Vishal, just if you can confirm on the chat window if you can hear me fine and if my screen is visible, which is good old Dilbert cartoon if you see on the screen, just confirm by. Okay, perfect. Thanks. Great, guys. So the topic today is data engineering for scalable analytics, and of course, my views today, which I would be presenting, and my take on the topic would be biased a little bit based on my experiences, and of course, this is something which is kind of problem which is in play. A lot of frameworks still are under development. Few companies have matured in the area that they have their own custom frameworks out there. But some of the best practices have starting to emerge. Some of the concepts have starting to emerge. Some of the tech stacks have starting to emerge. So I'll give you my view on that, and then some of the slides will kind of take some inputs, will solve take some of the inputs together from the audience, and then later on we'll open up for question. And as Vishal said, keep putting them in the chat window. Don't wait for the later stage, and we'll take it at the logical point. Right. So I think this kind of gave you an opportunity to look through at least uh, the. Okay, hold on. Vishal, just a confirmation. Do you see my panel window as well while I'm sharing my screen? If
Uh,
yes,
well, I'm seeing your screen. I'm not sure about panel. I have my own panel, so don't worry.
okay,
Go ahead.
great, great, awesome. So before I begin, a little bit about myself. I basically started VCubC data analytics a couple of years back, and before starting even VCubC, I got lucky to start working with today it's one of the larger NoSQL database in the market, pure play vendor, MarkLogic, and and with that, I kind of start getting an exposure onto the NoSQL side early on, and basically then kind of started learning a lot of other big data technologies, and in the process got a lot of opportunity to work with global clients on some of the big data projects that they were implementing, including NoSQL, Hadoop, Spark, and so on. Total 18 years of experience, and if you want to kind of later on connect with me on LinkedIn, you can find me with Ashutosh Agarwal, and or if you do a search on VCubC, that would be a better find. Okay, so moving on and coming directly to the topic of interest, right? That's why all of you are here. So, what is really a scale in the data analytics project? Right, and if you think about it very quickly, which comes to our mind is probably the quantum or the volume of data that is there, and that's kind of continuously increasing, and the real time data kind of makes the problem even harder to solve. And then if you're sitting on the little bit on the data science side of this problem, you start talking about number of variables or the aggregation queries that you need to do on the complex data sources, which you need to use in your algorithms or the reports which you want to build for your business user. Right. So what else really is there for a scale? Right, so let's try to complete this list below. I would like all of you to quickly put it in the chat window. What is your understanding of scale? Okay, and I'll take it from the chat window and populate that list here. Okay, so let's take about 30 seconds for that. Everyone, if you want to put in what do you think apart from these two things that I mentioned is basically scale problem for you in the analytics project that you might already be doing. Anyone? Uh, it would be kind of more interesting if we kind of start thinking in that direction and kind of put in something which we think which we have been struggling with on the scale side on the analytics project. Otherwise, I'll show you what my take is on this problem in the next slide.
So, Ashutosh, are you able to see the chat screen?
I cannot actually.
Okay,
Hold on.
okay. I'll tell you the answers. Some of them have come here. So
Okay.
somebody is saying variety,
Okay.
performance,
Performance.
pace
Okay.
slash speed slash cadence of delivering results from analyzed data,
Cadence of delivery.
results from analyzed data.
Okay.
Then multiple variety of large data sources or disconnected data sets.
Okay. Disconnected data source, which I'll put in along with the variety. Thank you.
No, data sets, he said. Disconnected data sets.
Yeah, data set source.
Okay. So
Yeah.
handling data with varying data points,
Okay.
velocity.
Varying data points.
Now, others are almost similar, multiple systems and their data or multiple data sources, and then real time.
Awesome. Let me put real time with velocity. If you
One
guys
more, effective collaboration.
are collaboration, right?
Right.
Within the teams. Okay. Great. Great, guys. All great answers. Thanks for that. So let me just put that screen up again. Yep. So all problems that we have seen while we kind of start scaling in the data analytics project, and very true. So let's see my take on this. So my perspective on scale, if I want to kind of classify that onto three areas, and some of you have kind of already mentioned that, is how many different data silos is spread across multiple systems can we integrate, right? That's one classic problem that we have to kind of take care of. And then along with that, if say to give you an example, a life insurance company acquired 150 different HR systems during the acquisition activity that it did during last 100 years, and each 150 systems having different schemas is and could be coming in from different legacy data sources, right? So a problem at scale that they need to solve, and then kind of integrate all of that together to build a 360-degree view on that kind of a data source and to implement the analytical solution and reports on top of that. And that kind of also brings in the problems of master data management and the veracity in your data source. Also, when you are kind of bringing all of that data in, you need to have the provenance, how the data came in, some kind of a trail, audit trail that you need to meet the government regulations and compliances, which becomes even important in kind of domains like if you're working with, say, pharmaceutical companies or financial organizations and so on, right? So that's one kind of uh, scale problem that you have to deal with. The second really is okay, you solve that problem for the existing data sources, Now you added new data source, or you added more variables or aggregation results to your analysis, right? On the same set of data, and the new data kind of coming in. Also, the real-time problem that some of you kind of mentioned earlier on, that the capturing real-time data or the velocity from the connected devices, which is growing at an even larger pace in this particular world. And the cloud neutrality. Now, this becomes very important because as more and more solutions are coming in the market, they kind of get tied to one of the cloud providers, and which is becoming important because you want your kind of infrastructure to have all kind of elasticity there, so that you can kind of scale it up or scale it out or scale it in depending on your needs. But what if, say, you get tied with the cloud provider itself, right? So if you don't want to kind of do that. You don't want to kind of get tied up with AWS. You don't want to kind of get tied up with Azure. You want that flexibility to be able to move around, right? So that's all part of your agility. And then another very important thing that comes in the scale is, how do we ensure data privacy at scale? Now, this is something that pretty much, when we are thinking about the first two problems, we kind of ignore in the earlier solution. But this is very important. Think about HIPAA, think about the GDPR compliances that European Union has put in. Now think about, say, you have a very good uh, operational database, analytical database available to you with all the data sources kind of captured incorrectly, MDM problem solved. But then tomorrow, if you need a data from there and you can't kind of separate out or kind of remove the personally identifiable information from that data source while kind of sending it to the downstream system for, say, analytics, you are burned, right? Because uh, these regulations are very harsh and will basically just kill all the ROI for your projects, right? So you have to think about your granular security. You have to think about encryption, not just for your data, but also for your logs, and also have to think about keeping that data preserved. Some of the industries would ask you to kind of preserve your data for, say, a couple of years, say financial industry for 7 years of data worth. So you will need to use your warm devices and basically something which can preserve that data, right? And then apart from that, of course, a very common thing that comes to our mind is the right amount of computing power, all the GPUs that you need, and the storage to do the job. And that horizontally distributed architecture, which is why NoSQL databases and the Hadoop became popular at the first place on the cloud environment, right? So if I go back, if I really go back and look at the screen that we created together, right? So if you say variety, the multiple data sources, performance, of course, is you need to be a performant, having a performant system. The pace of results, the connected devices, and the collaboration. Pace of results also tie down to if the agility part of it, which is if, say, a new data source comes in, what happens, right? How fast you are able to deliver the new set of results with the new set of variables, with the new set of data sources, with the new set of aggregations that you need to do on your data. Okay, so I gave you my take on the scale. Now let's start talking about, we discussed the problems. How are you solving these scale problems, right? So, of course, we have heard about scaling out versus scaling up, right? Traditional RDBMS databases used to kind of, as and when your data needs, your query needs used to go up. RDBMSs like Oracle would ask you to kind of buy a bigger and larger hardware and then basically dump the problem there. But with Hadoop, with NoSQL databases, the scale out became kind of one solution, which all of us know. The second thing, to this equation comes is, and again, I'll ask for your inputs, is how are you now solving these scale problems at your end, which you just mentioned, right? And Vishal, I'll take your help again to get the responses. So the first response that I'm looking for is, which analytical database are you using to solve the scale problem? Okay. And what other things you're doing to solve the scale problem, apart from scale out architecture and the right analytical database. So we'll take a couple of maybe 30 seconds or a minute to put in our responses in the chat window.
So Cassandra, Hana, Hadoop or Spark?
Okay, hold on. What's the other one? Hadoop. Hadoop, I'm not putting it in the analytical database category. The reason being, I don't consider Hadoop as a database. I consider it more as a framework. But maybe if you want to kind of put an HBase there, if you're using that. What was the fourth one, Vishal?
So only three responses have come: Cassandra, Hana, and Hadoop or Spark.
Okay.
One more, Redis.
Okay, Redis. Very good. What else apart from the database that you're doing to solve the scale problems, like the one that you mentioned about the real time, the one that you mentioned about agility of data sources? What are you doing for that?
Kafka.
Okay, so I'll put integration calendar. Right, so okay, so the data integration. What else?
Any more, guys? Nothing.
Great.
Yeah,
So I think
one
for the
more.
real,
I
yes,
think
please.
Nime, KNIME, Nime.
Is that correct?
Yeah.
Okay, great. Uh, yes, so yeah, so I think all great answers, and I'm kind of amazed that no one mentioned MongoDB here. I keep hearing that always, but that's good to know. But yeah, let's see my take on how to kind of go about solving this scale problem. And one of the classic issue that I see there is we are trying to solve each of the scale problem in their individuality in the silos, and therefore to get a connected end-to-end solution becomes difficult. Okay, so to simplify or to start solving this scale problem, I basically developed a DTD framework a couple of years back, which I use in my consulting projects. So if you see, there are three axes. It should be a 3D diagram, but just for kind of showing you. So if you see, there is a data preparedness index on the x-axis, then y-axis is technology preparedness index, and then there's another axis which says decision preparedness index, which is basically the crux. What you're looking for is basically to provide analytics to your business users so that they can take informed decision. That's the crux, or that's the overall goal of what we're trying to achieve in any analytics project. Okay, so business needs are basically a business strategy. Case studies could be found in, respective to the industries. What is the ROI that you're trying to look out for? And that is something that you should think about upfront. And we'll talk more about that in a bit. The second thing is your data sources. What kind of data source are you working with? Is it all legacy content, that is legacy plus unstructured plus hierarchical content plus binary content plus real-time feeds coming into your system, and this kind of has to basically solve both the capturing of the data and the storage of the data. Then the third thing is, how do you combine all of that together? How do you basically form a kind of operational database or an analytical database which becomes your source of truth, and you have all your governance and security layer applied on it, so that that appliance or that framework, that tech stack can then feed the data into your, sorry, into your kind of appliance or analytics appliance, which will then apply all your algorithms and the visualizations and the dashboards for your business user. Okay, so if you see this, this kind of is a very simplistic framework. Some of you will argue this is a common sense, basically, which needs to be applied when you're starting any analytics product. Right, so let's look at the first one, the goal setting, the business use case, and the ROI piece. Now, what I will do on next couple of slides is I'll tell you the classic problems that I've seen while working on the project and my take on how to solve them. Of course, it could be, again, as I said in the beginning, it could be very experience driven. You might have solved the problem a little bit differently than what I propose, and that's perfectly fine. This field is still evolving, and I would like to have those inputs. And if some of you have some additional things on the kind of slides that we would be discussing. So the first piece was goal setting, business use case, and the ROI. So the classic problem: you hired the best team, got licenses of the finest software, you purchased HANA, which is basically the costliest one, or some of you purchased IBM Watson and have all the data I need in the world. You basically got all the data approvals, you have all the data available that you need for your analytics. And in the process, you already burn 50-60% of my budget, but you really don't know what to do with that. Okay, so this is a classic case which can get you fired. I mean, you need to be a very good pal of your chief financial officer if you've already done that. So I think before even starting, go back to the whiteboard, set the clear goals, and then get a sponsor and buy-in from the leadership on these goals. You need champions as the guiding post. And the best way to make investment in big data projects is an incremental agile way. Okay. And this is not a one-time implementation. Do not go after unsustainable use case for too long, fail fast, adopt, and move on. Okay. But this is something that probably already know, and you would like to go as kind of peel one level and go a little bit deeper, and because most of us are coming from the technical background, so we would like to know a little bit deeper into a more specific engineering issues. So the challenge number one is, are you using the right technology to solve the scale problem? Now, we can argue, all of you mentioned different analytical database. When I asked about, someone mentioned HANA, someone mentioned Cassandra, someone mentioned HBase, right? And in your projects, some of these databases might have worked for the problem that you were trying to solve. Some of these might not have solved the problem that you were looking at as elegantly as you thought it should have. So one of the scale problems that we have already discussed, and this is, I think, this challenge number one is probably the most important one from the engineering side as I see it. You have a lot of disparate data sources, variety, right? And no clear data integration and transformation strategy. You don't know if a new data source will come in, how do you integrate that? How do you transform that? How do you make it available for your kind of analytics? What should be your ETL strategy? And the data science team basically continuously asks for the subset of data and more regularly. Okay, so To solve that or to choose the right technology, the kind of questions that you should be asking is what is the data extraction integration tools that you should be looking at? Okay, Talent, MuleSoft, NiFi, some of you said Kafka, and which can support multiple data sources. So what works best in your scenario? Okay, so of course you would need one data integration and extraction tool. The second is the NoSQL or the analytical database that you would need. The first poll question that we had, none of you said a big data appliance. Either you said the traditional RDBMS data sources that you were using as a kind of layer, or you were doing it from the file system, or you were using the NoSQL database. So have you looked at some of the NoSQL databases which can help you build these operational data hubs? And do they have a good governance and security layer? For example, can you do MDM in that? Can you do a provenance in that? Can you do audit trail in that? Can you secure them? Does it provide encryption at rest? Does it provide features like document level security? Does it provide features like redaction, which basically allows you to kind of when you export the data out of the system, you can protect the personally identifiable information out of that, right? So does your database have all those features out of the box? If not, what is a tech stack that you would be building out to basically support your use case? And then in some of the projects, we have started thinking about ELT rather than ETL strategy. With the schema agnostic databases now available in the market, schema agnostic means you can load the data without thinking about the schema of the data itself, and then do the transformation as per your read requirements. Okay, so you might also think about whether the solution or the problem that you're trying to solve, whether ELT, which is extract, load, and then transform strategy, would work better than the ETL strategy, which is a traditional approach of data warehousing. Okay, so that's another thing that you can look at. And these are not easy questions to get answered to. You will have to very holistically look at the kind of problem that you're trying to solve, the kind of data sources, right? And see a solution which basically is agile enough for your own needs. Challenge number two.
Ashutosh,
Yes.
before you go ahead, there's a question. Uh, how ELT is beneficial?
So ELT basically, the first thing is it will solve a lot of your real-time needs, right? If say you have data coming in from multiple data sources and it's coming in very quickly, you can basically load a lot of that data in without even thinking about their structures. Okay, and if you have a search layer available as a part of the solution, then they become immediately searchable as a kind of your search layer within your NoSQL database or as a third party solution. And then the transformation can be done based on your analytical needs. So what we like to call it more as a canonical model, where you can derive information from the source data irrespective of the source that it is coming from, and standardize that for your analytical needs, right? So that's where and most of the NoSQL databases which are available in the market today are schema agnostic. You can basically load the data as is, and then you can transform as per your application needs. Is there a follow-up question on this, or good to
No, go
move
ahead.
on? Okay.
Wait. I guess a typical Hadoop pipeline is ELT.
A typical Hadoop pipeline is ELT, yes, because you kind of put it in blocks, and then what do you kind of so a very simple example could be what kind of data type you apply while kind of doing a mapper or a reducer code on that can be done at the runtime based on those particular blocks, right? So that transformation or that analytics can be applied on top of it, or you can basically move that. But Hadoop is not a good example, or a Hadoop file system is not a good example in this scenario. I would rather take a little bit more advanced take on it is basically RDBMS versus NoSQL, where RDBMS we have been traditionally doing first level normalization, second, third normal form just to fit in the data which could naturally be fitted as a document model. For example, take a simple article that you see in your newspaper, right? If you want to now fit that information in, or a simple Twitter feed, if you have to fit that in into an RDBMS model, you will have to do a lot of transformation before you can fit that in, or you will end up loading it as a blob or a glob, which is not very usable. Whereas if you put it in a document database like Mongo or MarkLogic or a Couchbase, it basically goes in as is, and then that hierarchical model can be directly derived based on the kind of APIs which are available as a part of that database.
Thank you.
Okay, so the second challenge that I kind of keep uh, getting asked about is we don't have the right skills, and this is a scalability problem because uh, even if you have the right technology solution, you have data sources, you know how to solve that problem as an architect, as a kind of sponsor. If you don't have right set of people to execute that, your kind of model will not scale. You definitely need such professionals, right? So existing big data professionals are difficult to find and costly, and it's even more difficult to find people who understand the bigger picture. When I say bigger picture, what I mean to say here is there might be few professionals who know how to solve or how to use, say, a Tableau or a kind of Pentaho in a very good manner and write SQL queries to derive insights. There might be set of professionals who know how to do the transformation query either using Python scripts or JavaScript or in the core Java. There might be professionals who know how to use MapReduce, how to write MapReduce job. There might be now Spark professionals who might know how to use a Spark streaming or machine learning libraries, but they're kind of working in their silos. What is important to understand and to kind of grow and to kind of contribute, and because there is such less number of professionals in the market, is to have at least learn the complete stack itself, right? And which means is starting from what big data really is, what is a scale problem, what is a Hadoop, what is at least HDFS, because that get used. MapReduce is already kind of becoming legacy, even though a lot of people are still using the code that they've already written. Spark is kind of coming in very quickly. Then how do you say a Kafka or a NiFi or a Talend or a MuleSoft? And then at least one NoSQL database you should be aware of, because once you learn one of these technologies in each of these kind of areas, which is extraction and then transformation and the integration piece, the search area, the security and the governance, you will see that a lot of things get kind of repetitive over the projects. Only the kind of technology will change. The core concepts will start remaining the same. Okay, so that's kind of important that you learn that full stack out there. So of course, what we suggest is reskill your existing team. That's the best way because they are domain experts, right? They are already working on the kind of projects. So try to kind of teach them the full stack, either on the engineering side or data science or a little bit of both of them. and then try to get some experts from the market. Yeah, this is something that I'm trying to do. Uh, it's still not officially launched, alpha version. Uh, uh, it will kind of build these kind of learning tracks that for new age software professionals. So basically, say for data engineer, starting from data structures, Java, HDFS, MapReduce, PigHive, Kafka, NiFi, Scala, Spark, right? So if you do one cycle of this, you know the problem, and then if you do one project which kind of incorporates all of that, and apart from that, you will also need DevOps, the deployment tools, as well as the cloud technologies to learn. Okay, and then if you can also do data scientist along with that, which is if you can do algebra, statistics, Python, TensorFlow, AI, deep learning, and do a lot of on the engineering side. Um, I have known very few people who can do both very well. Right? So think about what you want to really do, what interests you, and then basically take that forward. Okay. But yeah, there are a lot of other kind of people who are doing that. So kind of make sure that you take a solution that kind of works out best for you. Okay, the challenge number 3: how can I reuse my existing infrastructure? And we have already spent millions of dollars on it. Now, this problem was more acute a couple of years back. It's kind of subsiding, but I think a lot of data warehousing is still kind of happens on the traditional RDBMSs. Like I think about 40% of you mentioned that on the poll that you're still using Oracle or SQL Server or maybe MySQL for your analytical database. And uh, organizations have spent millions and some of the larger ones even billions of dollars over the last couple of decades on these infrastructure. They just don't want to throw that away in one shot. They want to take a more incremental approach to that, right? So let's look at one of the data warehousing scenario to understand this better. So if you see the current RDBMS technology stack, this is how it looks like. So this is something that I was doing for one of my clients in the consulting projects, and kind of developed it out there. It's a little bit older, but nonetheless, I think most of it would still apply. So if you see, this is the current RDBMS tech stack for doing reporting, be it your descriptive or inquisitive batch reports, or OLAP, which was near real-time queries on the defined data, and the defined data was basically denormalized out of your different operational and distributed data, and kind of loaded into a data warehousing system, which was either Oracle or SQL Server and so on. And there were kind of different data integration tools provided by each of these vendors to kind of feed into that particular data warehouse. Now, the problem is this is not schema agnostic. And if you get a new file with even just 20, 30 variables, that will require a model change across. And if you try to kind of do predictive reports at terabyte scale, uh, it could take weeks, if not months, to just get out a new report, a meaningful report out of such systems. And then things are changing; they're kind of becoming more agile. But that's a typical timeline that you can look at. If you look at now an augmented architecture, wherein a client says, okay, I haven't spent a lot of money, I don't want to throw out everything. How do you kind of tweak this a little bit to fit into what I'm trying to do on the engineering side? So uh, what happened a couple of years back, where we started talking about Hadoop lakes, is basically people started putting out on the Hadoop file system what they had. in their operational and distributed data, and then they did a map reduce on top of it and feeded that into the data warehouse. And then from the same HDFS, there was a lot of work which was being done where they kind of start feeding into, say, an analytical tool like R. You could even put a Python or a TensorFlow out there and then do all kind of visualizations on top of that. And of course, now Hadoop, this is a little bit older one, but if you will see Hadoop getting replaced on top of HDFS, Spark layer is coming in, R is getting more and more replaced by Python, at least on the kind of organization side. But some of the traditional financial houses, you will still see R getting used prominently there as well. Right. So here you haven't changed everything that was happening. For the newer analytical needs, you have kind of uh, added a tech stack which basically supports, say, your real-time needs or more uh, AI or deep learning specific use cases, which can then be supported with this tech stack layer.
One question, Ashutosh.
Yes, please.
Why traditional databases can't be horizontally scaled?
Uh, they can't be horizontal. Why can't they be horizontally scaled? Uh,
Right.
that's how they have been built, right? I haven't seen a lot of Oracle systems doing that. Even though you can put them behind the cloud and say that we will manage that elasticity for you, but still I haven't seen a lot of that happening. If you have any use case in that area, I would definitely like to look at, but I haven't seen what traditionally happens with these RDBMSs is basically if you have to scale up, you kind of end up buying bigger, more costlier hardware for more data processing, or you can basically hid all of that behind a cloud layer as well.
Another
But yeah,
question.
yeah.
So, any details around data quality solutions you suggest?
So data quality is basically dependent on so there are a couple of questions if I want to kind of churn out multiple questions out of it, which will be more scenario based. One data quality issue could be uh, that it could be an MDM issue, which is same thing being called differently in different data sources, and how do you map all of that together? So you would need an MDM solution. A lot of NoSQL databases today I've seen are kind of trying to solve that problem, and that they are trying to come out with their own set of MDM kind of solutions as well. Another problem could be you are not even able to integrate the data sources, right? Because your tech stack does not scales that integration of data sources. Now, that is where you would need to again go back to challenge number one and figure out an analytical database which basically supports that integration of different data sources. Like some of those which are in market that I have worked with is MarkLogic is one of them, of course, which I kind of used personally on multiple client projects across pharma and finance industries. But I think pretty much all NoSQL vendors understand that. Another one that I've seen recently, which I was trying to figure out more about myself, is Snowflake, which is kind of RDBMS based, but I'm seeing a lot of traction happening with Snowflake in this area, and I see that already in the leader list of the Gartner Quadrant, Magic Quadrant lists. So Snowflake could be another one that you can look at. But yeah, how I like to kind of look at this is basically quickly go to the analyst report, and that will tell you who are basically the serious vendors on that particular list, and look at the people who are already either in the leaders quadrant or maybe catching up to reach there. Okay,
What will you say? How is Apache Griffin?
how is
Apache Griffin.
I I, I would I haven't used that a lot personally myself. Sorry.
Okay, good.
Okay, challenge number 4. I have team big data project plan ready, but no data access. Now, this is reverse of what you saw in one of the earlier problems of goal setting. That you did your goal setting, you planned for it, you had the right team, but due to the compliances governance issue, you didn't get access to data and you burned a lot of your budget on basically just solving those internal compliances issue. So again, this is not a problem on the engineering side, but more on the coordination side that one of you mentioned for the scale, right? So yeah, this is one of the coordination issues between multiple teams having trying to solve different equations, different parts of the same equation in a larger project, right? So as soon as you start planning, as soon as you have your project high level details in place, I think uh, think of it like as much time as you will traditionally used to take to procure infra, give the same amount of time to data as well, maybe a little bit more, and start requesting for those accesses early on. Okay, so that's what I had for today. And of course, any questions at this point? So I think to summarize, really,
So, Ashutosh, one question here.
yeah.
I see people process the data on Hadoop and load it back to RDBMS for analytics or reporting their consumption. Is that the right thing to do?
So you're going back to this one, right?
Right, correct.
Yeah. So this is, as I said, this was a solution to the problem where customer does not want to throw away entirely their existing infrastructure. If you would purely look at from the architectural point of view, and if you had the white slate, would you do that? No, you would not, right? But you don't have a clean slate. You have something already written on top of it, and you want to figure out how best you can fit in the new things on that, right? And you want to take an incremental approach, right? In that scenario, yes, this is a good approach to kind of start getting value out of what you're trying to do.
Okay.
Yeah, so see, I think data engineering issues directly feed into the analytical project scales. If you don't figure out the integration issues, if you don't figure out the real-time data feed issues, if you don't figure out the security governance issue, if you don't figure out the agility issues upfront, then including agility, the deployment issues, the DevOps problems, the cloud elasticity, the neutrality issues upfront, then down the line, you would have more time to spend when you start sending your data downstream for your analytics. Okay, so the sooner those problems are solved, or the better tech stack that you have to solve that problem, you would be in a better state. Okay, so again, as I mentioned about Data Analytics Hub, if any one of you have interest in that area, if you want to start kind of building your knowledge in that whole tech stack, then we are already doing some sessions via Meetup. Feel free to join that. Okay, and any more questions? I can take those now.
So we are open to questions now. Friends, please respond in question chat if you have any questions, and we have still 5 to 10 minutes, and we'll be responding to those questions. So question is, how do you see the future of HDFS when compared with cloud storages?
So I see HDFS will become commoditized as a kind of developer. You really would have to think about it as much as you have to think about the storage on your laptop or maybe on the machine that is provided in the cloud or S3, right? So it will get commoditized. You don't really you will think it like any other file system layer, really. That's what I think.
Okay. Any more questions, friends? So I think you have been descriptive enough that no more questions are coming.
Yeah, I think these are a little bit harder problems to solve on the engineering side, not as jazzy as you see on the data science side, where you kind of immediately get interesting outputs out of that. These are harder kind of problems from the perspective of a lot of coding needs are there, a lot of integration needs are there from the technology perspective.
Right.
So again, if you're planning to learn this or kind of that's part of your responsibility, then my suggestion would be to learn the whole track rather than just learning a single technology.
Okay. So there's a question which says, I have lots of doubts of technology level, like in NiFi scope. Can you conduct session for that?
So we have a course which is coming on NiFi and it will be launched in April. Check back or keep a tab on our kind of meetup group here, Data Ethics Hub. Right, so just join that. We have a session coming on Kafka this Saturday. NiFi would be sometime in April.
Another one, what DE nuances you would consider in the context of an ML or AI use case?
Can you repeat that again, Michelle, please?
What DE in capital, what DE nuances you would consider in the context of an ML or AI use case?
Right, so D, I'm assuming data engineering here, right?
Yeah,
Just
probably. Yeah.
yeah. So
Yeah.
so that's what we discussed, right? I think don't all the things that we talked about scale here. So to take a simple example, if you have to do a new aggregation query on the ML or the AI side on the data which is basically available in your data sources, is 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 your tech stack, is your analytical database uh, performant enough or scalable enough to take care of those aggregation needs as per your SLA needs is what a basic premise is. And to do that, you would need to make sure that you have all the components of the data engineering that we just talked about.
Okay. Any more sessions coming up, Ashutosh, on your front in coming weeks, which you can tell about?
So we are doing a lot of hands-on technology session on the tech stack. So there's one coming on Kafka, which will be delivered by someone in my team. And then we already have a couple of meetup sessions, tech hands-on meetup sessions that we did on Spark and HDFS and MapReduce. Recordings are also available on our Data Ethics Hub YouTube channel. And there will be repeat of some of these sessions in the coming weeks. So all these sessions you can join via our meetup group, Data Analytics Hub, and yeah, all of that is free as of now.
Okay, so since all of you are here, so another webinar we have tomorrow is for careers in AI and ML, which will be taken by me at 3 p.m. You can get details of it on the meetup group where you got the information for this one. And data preparation for machine learning on 18th March. Besides that, we also have a lot of meetups coming up, and you can be part of our group as well as Data Analytics Hub, and you'll be updated with all the details. Any more questions? We can take probably another one question, last question, although we have already reached 9 p.m. time. So any last questions you have or any last comments, Ashutosh, you would like to make for the audience here?
I think I'm good. Feel free to connect with me on LinkedIn, and I already shared the Data Analytics Hub meetup group link. So a lot of activity happening there as well.
Okay, one last question has come. So data engineering about embedding ML for data quality. What do you have to say on that? About
Uh,
embedding ML for data quality.
what do you mean by that? If you can give me an example on that.
So I'm asking the questioning guy here, if you can elaborate on the question. Uh, Using ML for data quality. Can you comment on that?
So using ML for data quality. Yeah, so okay. So let me give you a very interesting example here. I don't know if that kind of answers your question, but let me see. So there are algorithms like double metaphon, Levenstein distance, that you will see a lot of research reports on. And so like double metaphon, what it does is it basically is an algorithm which works on the phonetics, right? And if say a same user basically is spelled incorrectly in the system, say by a call support engineer, and typically kind of phonetically means the same thing, but the call support guy kind of put in the wrong spelling for that. For example, say a classic example, if I take my surname Agarwal can be spelled as AR versus RA, and phonetically if that matches, then these kind of algorithms, double metaphon, can basically help you in kind of an MDM activity. Similarly, Levenstein distance, which typically get used in things like spell suggestions. If you would have seen in on any search engine, you go and basically do a search and then it says, did you mean this? Right? So these algorithms typically solve those kind of MDM or the classic search scenarios. So some examples. Not sure if that answers your question, but some of these algorithms are now available as a part of NoSQL or the search engine kind of tech stack.
So, okay. So one last question about your meetup. Will Kafka talk be streamed online?
Yes, so the meetup that we do, it is available on web conference, as well as at the same time, people who can attend in our office, they can do that. And the link for the web conference is available on the event page itself. It's a standard link, and we use the same link every time for.
Great. So thank you, Ashutosh, and thank you, friends, for joining the webinar today. I hope you got value out of it. If you have any questions, you can send us on the meetup or directly to Ashutosh if you have noted Ashutosh details, and we'll try to get a response back to you ASAP. So thanks again for joining, and look forward to see you in future webinars. Thank you, Ashutosh, and thank you, friends.
Thanks, guys. Thanks, Vishal.